So now if we take a look at page number 29, we're asked a similar question. For number 17, it says to use the graph of the function f of x shown below to answer the following questions. First and foremost, I am tasked with finding the value of f of negative 9, meaning when I plug negative 9 into my function, what is my output? So if I look to the graph at right, and I find my x value of negative 9, I see that the output or the coordinate point in question there is positive 1. If I next have to find the value or the output when I plug 0 into the function, if I go to where my x value is 0, it looks like my graph of my function is going through the origin, which would mean that my output is also 0. It's crossing my y-axis at 0. To find f of 4 means to find the value of x, or the value of y, when x is positive 4. So I scroll over to positive 4, and I find where my graph crosses that vertical line. And the coordinate point that I find is the point 4, 8, meaning that my graph has an output of positive 8 when it has an input of positive 4. And lastly, if I'm tasked with finding f of 10, where the output of my function, when my input is 10, I see that that's just my very last end point on the right side of the graph. When x is 10, my output is positive 2. So when asked to find the values of x that solve the equation f of x equals 0, it means that we're asking for the zeros of the function. I'm asking for the x-intercepts of the function. So where does my graph touch the x-axis? And to do this, I'm going to take a nice, shiny, bright green highlighter, and I'm going to draw a line across the x-axis, and we're going to highlight the coordinate points where my graph can be seen touching or crossing that x-axis. And it appears to have 3 of them. And those points are negative 8, 0, and positive 6. And the next question that I'm tasked with is, how many values solve the equation f of x equals 4? So this means how many different inputs will give me an output of positive 4? And to do that, instead of drawing a line across the x-axis, I'm now going to draw a line across the equation y equals 4. And when I do that, I can see that there are 2 points where my graph does in fact cross the line y equals 4. Now those are tough to estimate, so it's a good thing that it just asks for how many values will solve the equation. And if I have 2 points where that horizontal line that we drew was going to intersect our graph, that means that there are only 2 values that would solve the equation. Now what is the y-intercept written as an ordered pair? That means what is the coordinate point for where our function is crossing the y-axis? And there's only one of those values, and it happens to be 0, 0. So then using interval notation, we're now tasked with finding the domain and the range. And like I said in one of the previous videos, the domain is the list of possible inputs. The domain is just all of the possible x values in our function. So I want to know the lowest x value that we see on the graph, and I want to know the highest x value that we see on the graph. And since there are endpoints on the left and right, it's very easy for us to find those finite pieces of information. So my lowest possible x value is going to be negative 9. And again, since it's a closed vertice, we're going to have a bracket. And the highest input that we have is positive 10. We see a positive 10 with a closed vertice, which constitutes a closed bracket. And when we take a look at the range, we just want to know the lowest and the highest possible y values. So I want to know, how low can the graph go? Does it go down low? And how high does it go? What's the maximum? So the lowest possible point, the lowest y value of my graph, or of my function on the graph, is -7. And again, closed vertex, bracket. And the highest possible value, the maximum, if I go up until I see my pencil start to go down, the output, the highest output is a +9. So my range of my function is outputs going all the way from -7 all the way up to 9. So now if I want my relative maximums, meaning all of the possible maximums, so not my endpoints, but just the points where my function is turning from increasing to decreasing, it looks like I should have 1 relative maximum. Because as we trace the graph, I've got a relative minimum, I've got 1 relative maximum at the point 3, 9. And then my graph starts to decrease again, and then increase to the endpoint. So again, if we now take a look to try and find our relative minimums, we see that we go all the way down and then turn back up at -1, which gives me an output of -7. So the point -1, -7 is a relative minimum. And then my graph is increasing to the maximum we've just found. If we go all the way back down again, my next relative minimum is going to be at the point 6, 0. So now for the absolute maximum and the absolute minimum, those again are going to be the points where I take a look and find the lowest and the highest value of my range. So those coordinate points are going to be -1, -7 as my absolute minimum, and +3, +9 as my absolute maximum, because those are the highest and lowest points on my graph. So now if we discuss the intervals for which my graph is increasing, we take a look at my absolute minimum all the way up to my absolute maximum, and the x values for which that is increasing would be the x values between -1 and +3. And then when I look at my next relative minimum, it looks like the x value of 6 is where my graph then begins to increase all the way up to an output of 10. So x is increasing between the values of 6 and 10. And then if I want to find the values of the function for which x is decreasing, I can start at my endpoint and see that my function is decreasing all the way down to my minimum, which is -1, -7. So from the y values, or the x values, my bad, the x values of -9 to -1, my function is decreasing. And then if I take a look at my absolute maximum, I see that my graph is decreasing from an input of 3 all the way to an input of +6. And so if we look at those two sets of numbers, I can see that my inputs and my outputs, or the endpoints of these increasing and decreasing intervals, line up with one another. When the graph stops increasing, it starts to decrease. When it stops decreasing, it starts to increase. There's the features of that graph and a nice full description.